Hello there. Today we're going to be talking about prime and composite numbers for sixth grade math. Okay, so first let's talk about what is a prime number and what is a composite number. Now you might be wondering, why are we talking about prime and composite numbers in sixth grade? I talked about this in fourth grade or learned about this in fourth grade. And the reason is because yes, you probably learned about this in fourth grade. However, in sixth grade, you're going to build on that skill and work on something called prime factorization. Prime being, again, prime numbers, and factors being factors of numbers. So this is kind of a review of what prime and composite is so that you're ready to do that. So let's first talk about what a prime number is. I'm going to write that here, prime, and then composite numbers. I'm going to put right here, but I'm going to abbreviate it just as comp. Okay, so prime numbers are numbers where the only way we can multiply to get that number is to multiply one and the number itself. So for example, a prime number might be 19 because the only way to multiply 19 is to do 1 times 19 or 19 times 1. Those are the only factors of 19. Another example is 23 because the only thing I can multiply to get 23 is 23 times 1. So again, prime numbers are numbers that the only way to multiply and get that number is to take the number and multiply it by 1. Another example, let's see, it might be something like, let's try 47. 47 is another number that the only way to multiply it is to do 1 times 47. So all of these numbers are what we call prime numbers. Composite numbers are all the other numbers. These numbers have multiple ways to multiply and get that number. An example of a composite number would be 4, because I can multiply 1 times 4 to get 4, but I could also do 2 times 2. So that makes it a composite number. There's more than just the one way to multiply and get that number. Another example would be 26. So for 26, I could do 1 times 26, or I could do 2 times 13. So again, that is a composite number. So most numbers out there are composite numbers, but there are a few very special numbers that are prime numbers. Okay, so let's take what we just talked about and use it to identify some prime numbers. So they're asking us which of the numbers below are prime. So we've talked about 4 in our example as a composite number. Well, let's just double check. 4, I can do 1 times 4, but I could do also 2 times 2, so that is not a prime number. 19, I can do 1 times 19, but I can't think of any other two numbers I can multiply to give me 19. So I would say that 19 is a prime number. Let's look at the next one, 11. I can definitely do 1 times 11, but I can't think of any other numbers I could use to get me to 11. So that is also a prime number. The number 2, I could definitely do 1 times 2, but there's no other way to actually multiply and get 2 for an answer. I know 2 is kind of confusing because you look at it and you think, oh, that's got to be composite. That's a factor in so many different numbers. But it actually isn't. 2 itself is a prime number. So I'm going to circle that as a prime number. Okay, here's our next list, and they're asking us which of these numbers are prime. Well, in the last example, we already talked about 2, so we know 2 is prime. Let's look at 6. So 6 is 1 times 6, but another way to multiply and get 6 would be 2 times 3. So that means 6 is not prime. For 13, we can do 1 times 13, and there's really no other way to multiply and get 13, so I'm going to call that a prime number as well. We also looked at 19 in our previous example, and we decided that that was also a prime. So from this list, the numbers 2, 13, and 19 are prime numbers. Okay, here's our next one. Which number from this list is prime? Now, it doesn't say numbers, it says number, so that gives us the clue that there might be only one, and that's okay, but we're just going to check them all just to make sure. So 28 is our first one. We know we can do 1 times 28, but we also know, since it's an even number, that 2 is a factor, because 2 is a factor in every single even number. So I know that 2 times something will get me 28. So I'm just going to go ahead and say that that is not prime. Okay, so we talked about 11 in our last example, and we decided it was prime. So I'm going to go ahead and circle that one. Now, the number 93, I can definitely do 1 times 93 as I can with all of these numbers. But now I need to see if there's any other factors or anything else I can multiply to get 93. It's not an even number, so 2 is not going to work. But I'm going to try some of the other prime numbers to see if they would work. So let's try another prime number such as 3, because 3 is a prime number. I'm going to take 93 and divide it by 3 to see if that works. Now, the reason I'm checking prime numbers is because if I can take a number, divide it by a prime, and get another factor, then I know that that is not a prime number. So 3 does not fit, or fits into 3, or sorry, fits into 9 3 times. So many threes. 3 times 3 is 9. When I subtract that, I get 0 left over. If I bring down the 3, 3 fits into 3, 1. 1 times 3 is 3. And I have 0 left over. So that tells me that 3 times 31 gets me 93, which makes it not a prime number. So I'm going to go ahead and cross that off. Okay, let's check the last one, which is the number 69. Again, 2 is not going to work because it's not an even number, but I can try it against 3. So I'm going to try 69 and divide it by 3. 3 fits into 6 twice, so I end up with a 6 here. 0 left over. Bring down the 9. 3 fits into 9 3 times, which is exactly 9, with 0 left over. Awesome. So that tells me that 2 times 23 are factors of 69, which makes it also not a prime number. So from this list, the only numbers that are prime is the number 11. Here is our next one. Which of these numbers are prime? Okay, so we've talked about 19 before, so we know that that is a prime number. Number 41. Okay, so I can think of numbers that fit into or multiply to make 42, but not 41. So I'm going to go ahead and say that this is also prime. 67 also seems like another number that I just really can't think of any numbers that multiply to make 67. 66, yes. 68, yes, but not 67. So I'm going to say that that is also prime. And the same with 53. I can think of numbers that could multiply to make 52 or 54, but not 53, just 1 times 53. So from this list, I'm going to say that all of these numbers are prime. Okay, here is our last list for today. This time they are asking us which of the numbers from the list are composite numbers. Okay, so they're switching it on us. Which one of these have multiple ways to multiply and get that number? Okay, so 79, I can think of numbers to multiply to get 80 and maybe 78, but not 79. I can't think of any multiplication factors to get me to 79. So I'm going to say that is a prime number and therefore not composite, which is what they're looking for. Now the number 9, I know I could do 1 times 9 as well as 3 times 3. So that is not a prime number and therefore is composite. So I'm going to say 9 is a composite number. 47, I think we talked about 43, but 47 is like right in between 48 and 46. Both of those could have 2 as a factor, but I can't think of anything that I could multiply to get 47. So I'm going to say that is not a composite number. That is a prime number. And the number 53, we've talked about previously. So we know that that is a prime number and not a composite number. So from this list, the only composite number that we have is the number 9. Well, thank you so much for joining me today, and I hope to see you again soon.